Welcome to May webinar, Telco Cloud Capacity Planning and Dimensioning. Thanks all for joining. I know it's Saturday, but I promise it will not take much time, less than 1 hour. So let me just start with some administrative stuff. So you can use the Q&A facility to post the question, any question. I will also do my best to see the chat, but I will rely on the Q&A, and we will stop after each section to see the Q&A. I'm targeting to conclude the webinar like by maybe in 45 minutes, so that we can leave more space for questions and discussions with all of you. So the topic of today is the Telco Cloud Capacity Planning and Dimensioning, and it's an essential topic because basically throughout the webinar we are going to understand the contribution and the involvement of such capability. I mean, doing the capacity for the cloud, how it is vital for the Capex reduction and potentially the OpEx reduction as well. So it serves like a main pillar in the way the CSPs monetize and stimulate the revenues. So it was there for a reason, and it is there to bring a certain value, which I target to explain in this webinar. So just like a quick introduction about myself, if this is like your first time to attend one of my webinars. So my name is Karim Rabia. I'm a principal architect, currently in principal architect in Red Hat. I had like previous roles with in different seats in system integrators and telecom vendors, in mobile operators. So I commonly see the technology from different angles. I usually try to bring that in a vendor agnostic content that I provide in the form of webinars or trainings. I have also some contributions in some of the SDOs and the like the open source community groups. So I'll always try to bring that kind of detail while assessing the technology. The topic of today again is the Telco Cloud Capacity Planning Dimensioning, a topic that I have worked with and I have seen from different angles, and I'll try to reflect that in the slides. It's only 40 minutes. We'll not cover everything, but at least that will set the stage or open the door for all of you to start digging and getting more information. Some items will resonate with what you're doing. Some items will resonate with what you are reading. I'll try also to bring my experience, hopefully, in the answers to your questions. So today, the structure of the webinar is as follows. I classified that into 4 main sections. First of all, to understand the importance of the capacity planning and the significance of capacity planning on private cloud or telco private cloud, you need to understand how the telco works. What is the business model of telco, and what is the significance of the Capex and OpEx, and what is the role and involvement of cloud in that. So that's what I'm trying to present in the first section. And then we will go through the process of capacity planning. I mean, how eventually the mapping or the forecast of the workloads of the core function of the 5G core, the 4G, the IMS, how this actually being assessed and being documented and eventually dimensioned in terms of licenses, in terms of resources. So you can say that section is from operator point of view, and then the XNF dimensioning and cloud infrastructure, I'm going to take it from the vendor or supplier's point of view. So with these 2 sections, I hope that I cover the overall process. And then the Telco Cloud Capacity Planning challenges. I'm going to talk about the common challenge that most of the operators face in terms of like over provisioning, under provisioning, or under dimensioning. And then I end up with some key takeaways. The webinar will be recording, and usually it is uploaded on YouTube, either like a chunk, like 1 hour, or split it into short videos. So let's start. And while I was doing the preparation for this webinar, I tried to capture some fresh insights uh, from the market to give you like the look and feel on how the financial equation look like, how the operator deal with the capex and opex, and what are the average ranges, and how the cloud contributes to that. So for me, that was the ideal start to quickly give an overview about the capex or the opex contribution to the overall revenue. So on the left, what you see is the average spending or the capex spending out of the revenue for these mentioned countries. So I took the case of the US and Australia and Germany because these are somehow developed networks. So we shouldn't expect that capex contribute to a big percentage of the overall cost, because most of the technologies are already developed. They are not in a starting of a specific wave. No, they have a very developed network. So what you can see is that capex contributes to 30 or 30 or 40% of the revenue. Okay. And when we come to revenue, we always have that term, which is the ARPU. Most of us know the ARPU. And the ARPU is actually the one of the most, I would say, well-known terms in the mobile technology or the mobile industry in general, which is the average revenue per user. I mean, what is the revenue that you get per user in your network in that specific country? For sure, the ARPU in the US is a little bit high. I was searching for the ARPU, for example, in Egypt, so it's far less. I mean, it was like around $3, maybe less. But what is relevant here is that in the US, for example, I took it as an example, the capex is a 30% out of the revenue. And you can assume, I mean, based on the market numbers as well, that OPEX may contribute also to 50 or 60. And then theoretically, that the rest is actually the profit. But 30% contribution to the ARPU comes from capex. And on the right-hand side, I also extracted some data, thankfully, from GSMA about the cost structure in different operators. So for the developed network, the average range is an average 25% capex and 75 opex. And as I said, capex here is low because you are not, for example, at the 5G launch, so you don't expect much capex to be put in place. While in developing networks, usually the capex contributes with a higher percentage to the overall cost structure. So now you acknowledge that reducing capex and for sure reducing opex contributes directly, right, to the revenues, contributes directly to the profitability. And it's not a secret that this was one of the motivations for the telco industry to go for even for the NFV in 2012. So that was one of the main motivations. One other insight or slide that I want to share with you to give you also the look and feel about the capex distribution is actually this kind of capex distribution that I got from Omdia, one of the research firms, and it is available online. So that was a report about the projection from 2022 to 2025. So somehow it describes the previous or the last 2 or 3 years. So what you see here, and what is very significant, and even for us people working on the mobile industry, 100% we understand that access network contributes a lot to the capex. So the sites, the antennas, these kind of things contributes a lot. And if you add, for example, the transmission, that will be a huge capex. And what was relevant also for me that the core part. So if you go, for example, like maybe 15 years back, before even the era of virtualization, the core used to contribute a lot, right, to the Capex. If you remember this kind of giant MSCs, media gateways, and the first generation of the packet core, and even the CS system itself contributed a lot. But now with the rise of virtualization, the contribution of the core a little bit, I mean, became less. But what you see now relevant, and that's a question, which is, can you spot the cloud infrastructure? So the cloud infrastructure, okay, contributes around almost 9% of the overall spendings or the Capex spendings. So now you can start to imagine that if you start to do like over provisioning and brings a lot of servers, a lot of license, that would contribute more and more to the equation, and then will have like a negative impacts on the revenues on how you monetize. So now cloud infrastructure in most of the operators, it constructs a good chunk of the Capex, a good chunk of the cost, and that is represented by multiple cloud stacks like Telco Cloud, IT Cloud, Enterprise Cloud. And here the talk is about the private cloud. So this webinar and even that diagram talks about covers the telco private cloud. We are not here talking about the public cloud, because if we talk about public cloud, that would take us to a lot of talks about the OpEx and not the CapEx. But here we are only, I'm only concerned with the CapEx. For the comparison between CapEx and OpEx, and that will be the part that I will end this section with. I also extracted some nice comparison for you just to understand the CapEx model of the telco private cloud versus whatever you have like a cloud service on public cloud, or the OpEx model. So the cost or the upfront cost follows the classic telco procurement way of work or way of doing stuff. So usually in telco, we invest, we build something, we pay upfront, and then we have like some sort of a plan or a strategy or a hope that subscribers will like the service and then purchase it, and then we monetize. So it has like a risk, right? Because you pay a lot in the beginning before you monetize. So imagine that a telco company wants to build a cloud, then there will be in the beginning a very high wave of investment where you start to build the data centers, build the infrastructure, the license it, and all the corresponding equipment. While, for example, in the OpEx model in the cloud, if you go to the public cloud, and we have seen some greenfield operators doing that in the States, you don't spend a lot on the CapEx. You like pay as you go. Like, for example, you take an offering from the cloud. If you manage to monetize it, that means that will be high usage. Then you will scale. Then you will pay. So it's like somehow it is drawn like a revenue sharing model, but you only pay when you get benefit. So that's a key difference. I'll not go through one by one, but I would take you to the last two lines because they are very relevant, which is traffic forecasting, okay, and the risk. Traffic forecasting, usually people who are working on telco cloud, telco private cloud, they follow procurement processes, okay? And to get an attractive commercial deal, if you have worked with procurement for, you cannot just go year by year. You cannot just go year one and then talk with a group of vendors, and then in year two you start to change. No. Usually you try to get an attractive TCO, total cost of ownership. And TCO, let's say it's from 3 to 5 years. So you try to get a deal with a supplier or a system integrator or whatever, like in a range of 3 or to 5 years. And that requires that whoever doing the capacity planning for the cloud, for the network functions, for everything, should have this kind of visibility, should provide the procurement with a long-term traffic forecast. And that's a fact. I mean, if anyone of the colleagues here have worked before in the packet core or the 4G core or 5G core, usually the procurement asks you for a 3 to 5 years roadmap. While in the public cloud, you don't care a lot because you have a flexible model. If you scale, if you go from 500 gigabit per second to 1.2 tera, you will pay, right? You will scale because for you are a user of the infrastructure. You don't own it, so it's the role of the public cloud provider. While in private cloud, because you own the infrastructure, it is very mandatory, it is very clear that you need to have this kind of visibility of the traffic. So this kind of mapping between the traffic, I mean, in terms of throughput, subscribers to CPU and memory and disk, this is something that I'm trying to bring in this webinar. So I hope you agree with me that there is a risk because you do an upfront investment. You are not sure 100% if this service is going to be adopted by the market, either externally or internally. But in the OpEx model or in the cloud model, it's a low risk because if you don't get traction, if users don't plug the service, most probably you'll not scale, most probably you will not pay a lot. So the key thing that I want to take from this section is that you are in the telco private cloud, you're adopting a classic Capex model, okay? Because you are following the classic telco procurement process, then capacity planning is now essential because if you do a poor capacity planning in cloud, you can end up with excessive costs. You bought a lot of data centers, a lot of servers. You went to the edge, but then you failed to monetize. So that's a classic risk. Or you underestimate the traffic forecast or the underdimension, so you end up with bottlenecks with service impact, and eventually you get the blame if you are the cloud owner. That will be this was the introduction of the webinar. I just wanted to set some important concept that will help us in the next section. So I'll stop here and see if there are any questions. We can tackle it. Okay, I have one question. What are your insights on serverless, like in AWS, since we are talking about capacity planning? So I'm going to take it from a general approach, okay? So adopting cloud native techniques, okay, contributes to lowering the capex and the operational costs. That's a key message. So whether it is serverless, what is this a cloud native, what is this XY, because every time we advance, we get new techniques, that definitely would help. But the challenge is whether these techniques are preserving or providing the answers for telco requirements and telco expectations. That's the thing. If this happens with the collaboration of the communities, the CNCF and the operators all over the world, yes, we can use these techniques, including serverless, the same way we are now doing like cloud native containerized 5G core, and like 10 years back we never dreamed of doing that. So definitely, yes, it will contribute. Okay, so okay, so I have one question. It's a very interesting question about the TCO. Okay, that in some operators they found that the TCO, total cost of ownership, okay, for private cloud is higher than the TCO of a public cloud. Okay, so and the question is maybe there is like a wrong capacity planning. So the answer is usually if you do a TCO, you need to provide the TCO with the right inputs, because on a high level, what is the TCO? Okay, from a helicopter view, a TCO, for example, you get like a specific deal or a specific agreement for 5 years. Okay, and that in 5 years, the supplier will provide a specific stack, and then will provide services to deploy, to implement, to make this stack operational. So these costs will always be segregated into Capex, like the hardware licenses, whatever, if the license is Capex, plus the OpEx per year multiplied by the number of years. So you get, like in 5 years, total TCO. So apparently, or initially, the private cloud, because the Capex is high, sometimes it gives the impression that that it's quite expensive, but maybe at the end, because of the lower OpEx, you get an attractive TCO. But the question here is that in some cases, the private cloud, telco private cloud had higher TCO. So you just think about what are the factors that contribute to TCO. Okay, maybe you overestimated, so you had a high capex. Maybe you didn't deploy the right automation, okay, to lower the service needed for the OpEx for make the cloud operational. So there are huge areas of improvement from the TCO equation, capex and OpEx. Plus, the estimation is or the capacity planning is essential. For instance, if you do a capacity planning from year 0, you get the deal based on that capacity planning. But the problem is that in year 1, in year 2, you start to get real feeds from the network, and that's something that we will discuss. So the problem with the capex model or with the procurement model, that there is no way back. You cannot, for example, get like return some hardware. No, you have to live with that for the whole TCO. So I agree, a big percentage of an not so attractive TCO in telecos resulted because of the over-dimensioning or the poor capacity planning. Other factors was not to be keen or not seriously taking lowering the OpEx into consideration, because there's a lot of things that automation, for instance, can do to lower the OpEx and make the TCO attractive. So I will stop at these two. I will take the other question. So there's another question about the Capex. I'll take it and reply to it offline, just to make sure that we are on time. Okay, so let's see the process. And I would say from the operator point of view, okay, it's a process slide talking about the process. Sorry. Oh, I lost the animation. Anyway, so in the telcos, and classically following the procurement process, to get a budget, okay, somehow you need to follow an internal process. That internal process brings all the requirements from different departments, from different teams, to some sort of a demand committee or some sort of an entity that have the authority to allocate or not to allocate. And then it groups all these requirements and then starts to approve and disapprove. So what are the inputs for this demand, or what are the inputs, okay, of these requirements or forecast? So first of all, each year, and I specified here the roles into two main actors that we always meet them, and most probably you have also interacted with if you are working with the telco, which is the green actor, which is the telco cloud team or telco cloud design team. Sometimes you can call them infrastructure design team, sometimes virtualization team. So those are the people who own the cloud and then provides this service as a service, either it's infrastructure as a service or platform as a service or container as a service or whatever as a service to the XNF team, CNF team or VNF team, or the application team. So it covers both IT and telco. So those are the two main actors. So usually the network function team, like the packet core, the IMS, they have their forecast on the application level, on the service level. Like I know as a packet core or EPC or 5G that I have this throughput in year 1, year 2, year 3. I have this number of users, number of whatever. Okay. And somehow I need to provide these values or these numbers, but also I need to provide the expected infrastructure resources needed to host this scope. For example, I'm packet core. I have a 500 gigabit per second expansion. But for cloud, this doesn't mean anything. For cloud, they need to understand how many CPUs, how many memory, how many disk, eventually how many ports, how many everything related to cloud infrastructure in terms of servers and infrastructure that we will procure to hold your workloads. Because in telco, the cloud infrastructure dimensioning or capacity planning is a workload triggered. So it comes from the workload. That's a fact, and that's the process. So usually the requirements or the forecast comes from the CNF teams. So classically, every year they have their forecast, and from the planning, they have like 3 years forecast. It comes also from the cloud team, either directly interacting with the demand committee or using the workloads as a tool or the media to come up with a requirements in terms of servers, and we will see that how. And it depends here about who owns the budget. And that's a very critical thing, because in telco private cloud, in some operators, the budget is owned by the telco cloud team. Okay. While in other domains, the budget is owned by the platform user, for example, the application team. So if you as an application team or a CNF team didn't get your budget approval, including the infrastructure on the cloud, then most probably you will not be onboarded on the cloud. So you go to demand by yourself, you get and like they accept your request to be onboarded, they accept your scope, and together with the other application owners or the application teams, all these requirements are grouped and fed to the Telco Cloud. That's a mode. Okay. The other mode is that Telco Cloud team directly group these requirements from the application, and Telco Cloud team goes to the demand or to get the approval or get the budget. So it might not look a technical thing, but it influences the process, how the process would look like. But eventually, it is requested technically from the technical teams to get the budget to understand this scope, the 500 gigabit per second, how it maps to the hardware. And that will be on the next set of slides. So you get, or you send all your requirements to the demand committee or to the CTO office or whatever in the organization, and then you get an approval of your scope that yes, packet core will expand, IMS will expand, CS will expand, security will deploy this number of firewalls, and this maps to this number of servers on the packet core. So this kind of approval triggers a process to start to do an RFQ, like asking the suppliers to provide these requirements. If you want an expansion on packet core or EPC, then you most probably you will float an RFP to the EPC vendors. If you are going to expand or have a new data center, then you start to talk with the like hardware vendors and software like Dell, HP, Cisco, or Red Hat, these kind of things. So you start to build your RFQ, either RFP or RFQ, to get the supplier quotation. Okay. At this stage, you have a forecast coming from these two players about the service. So you know from service perspective what will be the expansion, what will be the scope. On the network level, most probably you have the equation to reach because of the bandwidth and throughput needed, what kind of switches, what kind of networking, what kind of CDN capabilities that you want. And then most importantly, and that's the focus of the webinar, you have the forecast from on a cloud infrastructure level. So you send these requirements to the RFPs, to the vendors, and then you award it to someone. And then comes a very important step that is very cloud-centric and the characteristics in the cloud. So you did an RFQ, you pick the vendor who came with specific dimensioning, and then you deploy. Once you deploy, you start to see the reality. For example, if the RFQ required that that node or that network function supports 200 gigabits per second at 80% utilization of CPU. And that's the basis that we build the capacity planning on it. And then you found that that node can support the 200 gigabits per second while being on a 20% CPU utilization. So you have a lot of resources being wasted. Okay. So the expectation to have a closed loop operations and toolings and these kind of things should feed this kind of status or load utilization on how we do the capacity requirements, on how we do the design, so that we can optimize and avoid having the same issue or the same problem that led to wasting the resources. The problem with the telco environments, they are very rigid, and once the CNF or the VNF capitalize on the resources, for example, if I ask for a 50, if I ask for a 240 CPU, for example, and at busy hour, I only consume 160, then we have an 80 CPU that can be allocated to others. Most probably because of the procurement process and the way the CNF teams utilize the service, they capitalize also on the wasted 80 CPU, which is not like, which does not reflect a real capacity utilization in a classic public cloud. And that is one of the drawbacks or the issues on the private cloud. But the thing here is that year one, yes, you can have faults, you can have mistakes, but mistakes cannot be repeated in year two and year three, because you have already the feed from the live network. You know how this network functions behave. So having the same network function with the same resources or the waste of resources, this is, I would say, not a smart move, because we need to have this kind of closed loop control in the context of capacity planning. So this is like, from the operator point of view, let's just focus on the forecast. Because as I said, the capacity planning or the resources forecast on the telco private cloud comes primarily from the forecast of the workloads. So operators with the maturity, they get this kind of equation that you enter throughput, attachment, registrations, transactions per second, and you come up with number of servers with NIC cards with specific configurations. So let's take it just one by one. Okay, so now I'm zooming on the top left part where we have a request from a specific team, which happens to be the APC here, that I need to expand because I have a projection that the traffic will increase to whatever. So I have to increase with, as I write here, like year one, 500 gigabits per second, year two, and year three. So that's the throughput. This is just the capacity requirements. I can amend that with some design decisions to help the supplier understand how do I think, and help the supplier eventually to dimension. So, okay, I will go with 4 regions. Most probably I will put 4 nodes, P gateway and 4 nodes. It's N plus, so all of them are active. And you know what? One P gateway shall handle 50% of network traffic. So for example, if now I'm purchasing 4, 2 of them can serve the network, and 50% of the traffic can be handled at 80% utilization. So these are some high-level design decision. I do this for all the scopes. I do this for MME. I do this for all the other nodes if there are other nodes. And then I need, me as an operator, I want to give all the useful data or input for the supplier or the vendor to come with a proper dimensioning, because sometimes and I worked in both operator and supplier side. Sometimes because of the uncertainty or the broadness of the inputs coming from the operator, you get somehow an over-dimensioned nodes. You get maybe not so accurate dimensioning output. That's why in that stage, the operator should always put all the useful information for dimensioning in that stage. So these are the functional teams, okay? But the Telco Cloud team also, they have some sort of a framework that should be shared with all the suppliers, that, you know what, we have these features. These are the chassis that we are work with. These are like the processors that we work with. You know what, we have this placement criteria capabilities. You know what, we have the affinity and the affinity, or we have a strict requirement that you cannot put, for example, the pods or the VMs on this of the same DNF component on the same server. So you have to build as if you are like marketing your cloud, or as if you are creating a menu for your cloud so that you can share it with anyone. So these kind of inputs are the inputs that the vendor takes, okay, or supplier takes, and come back to you and tell you, you know what, in year one, okay, year one, you need 500 gigabits per second, 80%, and you have these features. I tested that in my labs. Okay, in year one, I'll give you this number of software license, okay, and that will run, I will need 340 CPU, whatever gigabyte RAM, whatever storage. And because of the equation that the cloud has, the servers are indexed, are categorized, are having profiles. So that would eventually map into a number of servers of profile X, number of servers of profile Y, just grouping the CPUs, and number of uplink ports, for example. And then same for year two and same for year three. So this is how the operator sees the process. So prepares all the inputs needed, okay, for supplier to do his dimensioning exercise, which is, by the way, will come in the next section. And at the same time, what we see is that design teams, and because of the, for example, if you are dealing with one vendor or multi-vendors for example, for the last 5 years, then you start to get the same sense. For example, you know now that if it is 200 gig, most probably these are like 3 servers, 2 servers. You need just to validate the new application release with your estimation. But with more work, with more maturity, these things started to be like an in-house developed tool that most of the operators have. But the classic case is that you give the inputs to the supplier, and then supplier comes back to you with the dimension. I will stop here and take one question. Okay. Okay, the classic question about the webinar. Yes, it will be recorded, and there is one comment about that vendors are not charging for equipment. They take responsibility to meet contractual requirements only, and rest all up to vendors. I will take this comment from Ahmed and talk about the important point that contracts are evolving. Okay, so procurements are trying to adapt and trying to get some sort of attractive deals and agreements that somehow can be a little bit close on what the public cloud is doing. Okay, so we see that in the last few years, the models or the engagement models between the vendors and the operators are starting to be more into like revenue sharing or partnership models. So it started to evolve, but still the Capex theme is in there. So let's just get straight. I'll show you the process from the vendor perspective, and then an example. Okay, I'm trying to reflect this theory in an example. So let's take it first from process perspective. So the vendor, okay, he gets the capacity requirements or the RFQ capacity requirements. Most probably, if it is a network function or application RFP, then the capacity requirement it's related to the network function KPIs, throughput, registrations, transaction, whatever. So usually the vendor expects from your side, from the operator, not only the capacity, but some clue about the traffic mix. For example, traffic mix for us, for example, in the EPC or the 5G core, is the packet size, distribution of the traffic, percentage HTTPS, percentage streaming. So this kind of inputs, at the end, it impacts the dimensioning of its own application. Dimensioning inputs and variables, for example, the redundancy model, what kind of redundancy model, the load distribution. For example, you mandate on the vendor that he has to give you the maximum throughput at CPU 80%, not 90%. So these kind of inputs he also takes it into consideration, and then he takes all these inputs and go to a very in-house developed dimensioning tool, usually they have, and then they come up with the dimensioning output. Okay, that dimensioning output, it's then tailored with the sales format to be a quotation. Okay, quotation with like BQ, like what are the licenses, and also quotation in terms of pricing. So at the end, you get a solution that tells you that, you know what, I'm going to give you a P gateway, for example, in the example P gateway. That P gateway consists of 3 components. Each component requires number of VMs or number of pods, and each VM require this number of resources. You get a solution, not a very concrete one, but at least a high-level solution. You understand the architecture of the provided solution. So how this vendor does that, I tried also in an informative way to give an example. Okay. So you gave him your dimensioning the dimensioning inputs, right? You gave him the capacity planning figures, right? He knows that, for example, the node that he has to provide should, for example, cover 3.2 kilo K transactions per second. He knows that he has to support 300 gigabit per second. He has to support number of encrypted sessions. So you gave him, okay, the dimensioning inputs. So for sure it differs from vendor to vendor based on how he architectured or how he built the software architecture of the application. But in general, there is always a benchmarking and there is always a continuous validation happening at the vendor's lab that will allow him to come up with an equation that tell you what, you know what, in my application, in my network function, under these circumstances, under these inputs, with the right benchmarking, one CPU can handle 600 transactions per second with this traffic profile, with this traffic mix. And you know what? From my testing, from my benchmarking, that every once virtual CPU needs 2 gigabyte of memory, of RAM. And based on my benchmarking and my testing, and even with participation in the certification programs, I know that it needs an additional memory of 10%. And I will add, for example, a safety factor of 20%. So you start now to see the formula that eventually will turn the application metrics or dimensioning metrics like throughput and SAO and whatever into a CPU and memory and disk. So eventually he will come with you and he'll come to you and telling you what, you know what, my VNF XX consists of 4 VNF components or consists of 4 different pods. Okay. And the control plane to cover your traffic profile, it requires 4 VMs with this flavor, 14 CPU, 32, whatever, 1.2 terabyte disk. And then there is a component for user plane and component for security and component for O&M. And you bring the resources. Usually when we do the evaluation of the RFP, the one that comes with attractive internal architecture and less resources requirement, this should be always number 1, because it gives you the impression that yes, my application is somehow a cloud native, that it will not eat your resources and to provide the capacity that you requested. Okay, so I hope that was clear. I mean, how the operators see it, okay, and then eventually how the vendor dimensions the solution and provide this kind of capacity requirements to you, for you to avail these resources to him as part of the capacity preparation on the cloud. For instance, if you take this supplier and you awarded the scope, then he expects when you ask him to onboard his application that these resources should be there. For sure, plus some other design inputs like affinity, anti-affinity, how these VMs are distributed across the servers. I'll stop here and take a question. All the questions I will take it offline, but just I'm trying to not go beyond 1 hour. Any questions? So please, can you use the Q&A? I mean, I cannot see the hands. Okay. We have one good comment about the J redundancy. That's an input for dimensioning. Yes, 100%. I mean, the DR as a concept is a huge input to the equation. Okay. So what are the challenges, current challenges? And I picked only two main challenges. First one is the over provisioning, that you find that at a certain time, your cloud infrastructure is very underutilized. The CNF utilization at the busy hour, which was supposed to give that kind of serviceability at 80%, you find that it is serving the expected throughput, for instance, with only 20 or 30%. So there is like a general underutilization or low utilization of the resources. And then usually now what we see is that telco customer, telco operators are very now interested to get solutions that shows them the value or show them the cost optimization or show them the contribution of the cloud to the overall cost. So usually a classic audit, okay, can bring concerns because you ask it for this budget, for this scope, but you know what, after 1 year, we have this kind of resources loss or resources or wasting resources. Why is that? Because maybe the forecast, the traffic forecast, the 500 gigabit per second was overestimated. So it's a mistake coming from whoever done the planning for the service. We put a lot of safety and risk factors. I mean, vendors who worked on the dimension, they know that. We usually put 20%, 10% under different labels just to account for this kind of safety and risk factors. Improper infrastructure dimensioning. So the service dimensioning or forecast was accurate, but the way the infrastructure was dimensioned was a little bit high, was over dimensioned. Or the fourth point, which is very interesting, is that from cloud perspective, if you see the cloud is underutilized, this doesn't mean only that there was a poor capacity planning exercise, but maybe there are obstacles, okay, that prevents the CNF vendors or CNF teams or application teams to be onboarded on the cloud. And usually this is the cloud operational model. You have a legacy operational model, you deploy a cloud, you start to apply the classic operational model on the cloud, it doesn't work. Then you find most of your users are going into silos, are going into single vendor stacks, are going to custom solutions, are not adopting your cloud because there is no clear operational model. There is no clear onboarding process. So they don't know actually how to be onboarded and what will be the operational criteria. For instance, that is usually one of the reasons of having a low utilized or a cloud which is underutilized. Correction and remediation path, it is the classically the relying on the elasticity or the characteristics of a real cloud. Okay, for example, if you are going to dimension, why it is a must to put the solution based on the spikes or based on the busy hour? Why can't we start with some minimum configuration while you are confident that if there's a spike, if there's increase, you start to scale? So this is one solution, and this looks like what the public cloud is doing. Second thing that we have seen that a lot, that you find that a specific cloud is underutilized while another parallel stack holding another workload is overutilized. And there is no way to do this kind of resource pooling. So if you have a real cloud, then you have to have the right solutions that guarantee to you the resource pooling. And there should be a governance in the operator that allow these resources to be shared. Not every team capitalize on a static set of resources. Third thing, which is very important, which is the loop, the closed loop that you deploy. Okay, first year it is over provisioned, underutilized, then get the feed to capacity requirements, to the design, and do not do the same mistakes. See what were the mistakes and see the loop, see the feed that's coming from the network, and then redesign, retune the parameters to make sure that this is not happening. In the same story, the under provisioning, which is a little bit tougher because under provisioning may cause service impact, and service impact in telco may impact the revenue. And if there's a revenue loss, that's a big thing. Okay, so revenue loss, it's a big thing. So observation, if it's under provisioned, that the infrastructure itself is heavily utilized, the XNF or CNF utilization is very high at the busy hour, and there is a service impact. There is a bottlenecks. And that's classically improper infrastructure dimensioning. The traffic forecast was underestimated, or we saw that many times that a specific network function misbehaves, like it does some unpredictable behavior, doing spikes. For example, a specific module or microservice, because of maybe misconfiguration, it consumed a lot of CPU. So we have seen that sometimes network functions misbehave. So the remediation here is something that we see nowadays. I was talking about that contracts are being evolving. So I saw many commercial agreements that ensure and guarantees that if there is any kind of shortage of resources, there will be always ad hoc expansion. Agreements that guarantee the existence of a stock of the same hardware in the data center so that we can quickly, in an automated way, expand. And commercially, there is a model that allows that. Second thing, which is a very nice point and interesting, and I get these questions a lot, which is actually, okay, you get a spike, you get a demand for resources, but you don't have a procurement cycle. So why can't you expand on a public cloud? Why can't you make use of the hybrid cloud approach? Hybrid cloud approach, what you see is that you have an umbrella, you have a multi-cluster orchestration, or you have some sort of a manager that can control the onboarding on the two clouds, in the private cloud, on public cloud. So that, for example, you can quickly expand the public cloud, like for example, onboard an application on the public cloud to resume the service if there's a service impact. So having this kind of solution, or a hybrid cloud solution with a hybrid cloud or multi-cloud orchestration, can help you to survive in these situations. And for sure, the feedback that coming from the loop, from the cloud, to make sure that you don't do the same mistakes in the planning or in the design. I have 5 minutes. I'm going to say some key takeaways, which is like summarizing the topics. And then I'll have a look on the questions and the answers. So quickly, it's a Capex model, okay? So we all understand that. So the way we procure the cloud, I would say, unfortunately, it's still following the Capex model. And that mandates that we follow, okay, or that mandates that we should have a strong capacity planning process backed by AI, backed by technology. Why? Because any kind of mistakes here will impact directly the cost. Second thing, that this kind of process or the complexity are coming from the complexity of the procurement process, and it by itself it's not optimized for cloud. Okay, so the way we do the mentioning procuring, this is not a cloud or cloud based or cloud native process. No, it comes from the legacy on how we used to procure towers and antennas and these kind of things. Over provisioning or under provisioning, this is very normal at the initial waves. When you are setting up a cloud, it is normal that you don't have this kind of maturity, you don't have the tools, the technologies, but starting from year one, having the feed from the cloud, this should help you to have or to optimize or to enhance the way you do the capacity planning. Last point. As we started, there was one question about questioning the TCO of the private cloud. And that's now you understand that if you have a proper capacity planning, it will always help you to bring an attractive TCO. If you have a poor capacity planning, that will kill the TCO. Okay, so that's the direct relation between the capacity planning and TCO, because if you manage to dimension properly, you manage to reduce the capex cost, you allow more space for revenue, you bring more revenue to your organization. I talked about the capex, but I all invite you to see the overall picture, because it's not only capex, OpEx, which contributes usually to 50-60% of the ARPU, can be also enhanced by other techniques, and I hope that can be like the topic of next webinars, like the automation, for instance. So these are the key takeaways for today. We are on time. I have 2 minutes. If there are any specific questions, I can take. If not, I will take it offline. So there's a request about separate session on hybrid cloud use cases. Yes, I'm planning to do that. Anywhere hybrid cloud tested in your experience, especially in EPC node? Not in EPC. Usually they scale in the control plane. They scale on having clusters for PCRF or for OCS. I didn't see actual user plane or control plane traffic going through a hybrid cloud model, but if I manage to find one, I will share that on LinkedIn and hopefully tag you, inshallah. Where and how AI can assist in capacity planning. So you saw the process, you saw the equation, and you acknowledge that there are inputs coming to this equation and output. So that's a classic use case for AI. Okay, so the same thing that operators do and vendors do, that can be grouped in an intelligent app that can get these inputs and then predicts or brings the expected output. But that's a very interesting. I believe I will have to complement this session with a part about how AI contributes to that. So thanks for this question. Okay, thanks a lot for your time. I hope it was, helpful for you and for all of us. I will be sharing the video on the YouTube and on LinkedIn. And thanks again, and hope to see you in the next webinars.